A milling machine is a machine tool with a rotating cutter, typically used to shape, slot, and drill solid metal workpieces. Most machines have three axes of movement, X, Y, and Z, the same as those of the Cartesian coordinate system. On a manually operated conventional milling machine, the milling table can be moved side to side along the X-axis using one of two hand wheels. The table sits on a structure called the saddle, and together can be moved transversely along the Y-axis. The spindle, which holds and rotates the cutting tool, is housed in the milling head and can be moved vertically along the Z-axis. Z-axis movement can be accomplished by moving the entire head vertically along the column. Alternatively, the lever-operated quill can provide rapid vertical movement for operations such as drilling. A vertical machining center, or VMC, is a computer-controlled CNC milling machine. Movements are very similar to those of conventional milling machines, with the table moving along the X-axis, the Y-axis, and the spindle head moving vertically along the Z-axis. Machine structures such as the table, saddle, and milling head slide along a set of rails. Some machines use linear motion guides, which are low in friction through the use of circulating ball or roller bearings. Other machines use cast iron box ways, which can be more rigid at the expense of added friction. Hand wheels are used to apply power for axis movement on manual machines. Highly accurate servo motors are used to apply power on automated CNC machines. Lead screws, such as the Acme screw on this conventional machine, translates rotational movement into linear motion. CNC machines use ball screws and ball nuts. Ball bearings which circulate within the ball nuts reduce friction while increasing accuracy.